Hello and welcome back to the Rubber Duck Developer. Today I want to talk a topic that I should have covered much earlier before I did my first cucumber diseases video, but I was so curious and proud about the project, so I wanted to start getting coding. So today I want to talk a bit about the theory involved in behavior-driven development and how you do that with cucumber. Yeah, I should have done that much earlier. So this covers kind of the basics, and if you already started the cucumber diseases series, maybe watch this one here first to get some basics covered. Or if you didn't, then well, watch this video and then start working on the cucumber diseases series. Although this one may also be just the first of a series where, in this video, I'm just going to cover what is BDD and some basics on how we do that with cucumber. And then maybe there will be some further videos to deep dive into what's happening behind the scenes and what makes that, so using cucumber for BDD, a bit different in terms of software development and what are the specific challenges and coding smells we come across, why we initiated the cucumber diseases project. Okay, so let's get started talking about BDD. First off, I want to cover some basics on the theory behind BDD. Let's start with a big question on what is BDD actually. So BDD stands for behavior-driven development. It's an approach that spawned off the agile movement of software development. So it deals a lot with collaboration, and that's the first key point to have in mind. BDD is not just something about, or not just some approach about, this is how you code your software, or this is how you test your software, although it's often put into the latter corner. It's more about how do we work together to craft useful and working software for a user. It's all about interacting, communicating, and collaborating from early on the software development process. It's an approach that is intended to create a shared understanding between all parties involved. So it works best if you really talk to the user of the software, what they need, what they want to do, and then even bring them in maybe formulating the different scenarios that we'll come later to. And BDD has an emphasis on everybody. So product owners, business analysts, designers, testers, software developers, working together throughout the software development process. So this is really something where we take one step together and then the next step and then the next step. So as a second part, it's called behavior-driven development. So it has a lot to do with behavior. So what's the behavior that we're talking about here? BDD tries to capture the way and behavior of the software as the user interacts with it. So you always have to keep in mind any user of any software product uses the software as a tool to accomplish a goal. And we want to understand what behavior they require from the software to do that. So it's very important to figure out how do they interact with the system, how does the system react with them, what happens between them. So in BDD, we always implement and verify the user behaviors and application behaviors step by step, and every behavior that we come across starts with the user and ends with the user. Let's talk about an example with BDD with an ATM. Let's say we are writing software to operate a money machine out there on the streets, and I want to understand what it has to do. So I'm going to figure out and ask users, what do you want to do with the system? What's the problem ahead? And people will say, I want to withdraw money. So what do they want to do? They want to walk up to any public ATM and just go there and get money from it. I can easily understand that there are two different scenarios involved in that, a positive one and a negative one. That's the easiest that comes to mind. And so scenario A in that behavior would be, scenario A in that behavior would be, you have sufficient funds in your account. So what's going to happen? You insert a debit card, you enter your PIN, the account shows you have sufficient funds, and then you withdraw 200 euros. The ATM dispenses the money to you, you get your card back. By the way, I use euros here because I am in the EU and I don't really care about currency in that example. The other case that might happen, and we can easily spot that, is you do not have sufficient funds in there, so you insert a debit card, you enter the valid PIN. So far it's the same thing, but maybe your account will only flash that you have 100 euros, you want to withdraw 200. What happens then? The ATM displays an error, you get no money, and you get your card back. This is the way how we capture behaviors in BDD. So the behavior of the system that we want to capture here is withdrawing money from the ATM. And we specify these behaviors by providing scenarios of how our software system and our user will behave. Each scenario describes its own behavior. Like, I want to withdraw money but have sufficient funds. I want to withdraw money and have insufficient funds. And in both cases, there's different behavior of the software involved, and we capture them by specifying these examples. So this is the informal language, and this is how we understand behavior capturing with BDD. But how does it look in a bit more formal way, and how would you develop through that? So let's stay with the ATM example that will accompany us until the end of the live coding part. So in BDD, we call withdrawing money a feature. A feature describes the large end-to-end behavior. In that case, it could be withdraw money from the ATM with a debit card. We then start to investigate what are the different scenarios that describe the full behavior. Like one scenario is we have sufficient funds in the accounts. How does the system and the user behave in that case? We describe that. And other scenarios like we have insufficient funds. There are even more, like you want to withdraw it, but you enter the wrong PIN and your card is denied or your access is denied. Or even one that's pretty interesting because ATMs have this little box of cash in there. So what happens if everything's good, you have sufficient funds, you have your PIN entered, all good, but the ATM is out of money, it can't dispense it. So these are different scenarios of the same behavior. The behavior is always the same. The behavior is you want to withdraw money from the ATM with a debit card, and this is how the system behaves in different starting situations or in different situations. There will be even more features or behaviors you want to cover. Like maybe you also want just to check your account balance, where on the one hand you are from the same bank or it's a foreign bank. There may be different things involved, or even some completely other stuff. If we approach such a software from a BDD point of view, what we want to do is we want to deliver behavior after behavior. Each behavior represents a useful functionality and feature for the user. So if this is a ranked list of behaviors, like we know the first thing we want to cover is withdrawing money from the ATM because that's the core need of the user, we are setting out to deliver this with our team, like deliver feature 1. In order to do that, what's going to happen now is we are starting off the first scenario or the first concrete behavior, which is we have sufficient funds in the account. We start working on that. So we specify the scenario, we implement it so that it works, and at any time we can verify that it works. And once we have that implemented and verified, it is done, and we move to the next scenario, implementing all the specific cases that rise up there. It goes the same way. We define the scenario. After we have the scenario defined, we start implementing and testing it continuously. And then we go to the next one, which is like the wrong PIN was entered. Then we go to the next one, the ATM box is out of money. And once we have all the scenarios for that feature or that behavior covered, we have that done and we move up to the next one. So what you have to keep in mind here is, with BDD, at any stage in the development process, we have the goal of automatically verifying whether the system behaves correctly and interacts with the user correctly. So we always start with the user and we always end with the user. And at any point we try to, have that end-to-end testing and verification done. Let's take a look at how in a BDD approach we structure our, you could say, requirements. As I said, the top level is the feature. Within the feature, we define a scenario, and all scenarios work through the same 3 steps. Define the initial conditions and context where we set out, execute a specific behavior of the application, and then verify whether that behavior resulted in the expected end state. And we do that for multiple scenarios. How we do that, like the anatomy of a scenario, is based on these 3 columns. So scenario is captured in that way. Given the account balance is 200, when I withdraw 150, the remaining balance is 150. And this given, when, then annotation is how we specify BDD scenarios. The language that's used here is called Gherkin for these little cucumbers. And we capture each scenario in that 3 steps. Like given, this is the precondition. When I do that, then we end up in this situation. Of course, not every scenario is like as simple as this one here. Maybe there are more preconditions to be met, or maybe there are more things to verify in the end state. So this is why we also have the 4th keyword, which is end. So a full scenario could really read like this from left top to right bottom. Given the account balance is 200 euros and I enter the right PIN, when I withdraw 150 euros, then the remaining balance is, it should say 50 euros here, by the way, and the card is returned. So this is, we write all scenarios down in this way, and you can do that in a plain text file. So how does that look out in the wild? Here is a feature I, for the same use case of withdrawing from an ATM by card. So this is what you can just plot down in a simple text file. Like we said, feature, colon. The feature is cash withdrawal from an ATM by card. Then comes a small feature description. By the way, you're not going to see that fully. Let me move over here. Okay. So then there's a feature description. This one is, for example, a user story, but it doesn't have to be. That's just some random text to help us understand what the feature is. Like this one, I just plotted it down as a user story because that's what I'm used to. So I said, as a bank account owner, I want to withdraw cash from the ATM so that I can access my money whenever I need it. And then we start plotting down the scenarios. And as I said, they are captured in this given, when, then annotation. So we say scenario, the account has sufficient funds, given the account balance is 200 and the debit card is valid and the ATM contains 1000 in the money box, and I entered my PIN correctly. When I withdraw 150, then the account balance should be 50 and the card is returned. So what's the cool thing about that? This is an annotation that doesn't require any specific software engineering knowledge to write down. It doesn't even require any specific requirements engineering knowledge. This is something you can do with your users, and that's where the big strength of BDD comes in. You can do that, and I did that with users. I asked them, how should the software behave? Here's a bit of vocabulary. Like, we have this features, and we have this is a scenario, this is an example of one interaction you as the user will have with the software or the ATM in that case. And there are some keywords like given, when, then. And then just sit down with the user and let them write these scenarios, and they come up with a lot of them. And they may be very specific or very generic, but we can use that as a starting point for developing our software. So if I would go to develop that, I would take that scenario, implement an automated test for it, and then start coding it until it's green and it works. And it is automatically verified that it works. And then I would pick the next scenario, which maybe I have insufficient accounts. It will look a bit different. And that's essentially how we do BDD and how we write requirements in BDD. And as I said, the strength is we can start collaborating here with the user. When I give that to somebody who understands how an ATM works, they will be able to understand the scenario. They will be able to give me different examples. And so we can evolve step by step. And when implementing that, we're only looking at implementing the minimum that we need to get it working. So that's kind of the how do we write this and what is BDD side of things. Let's talk a bit about tooling. BDD, and especially the Gherkin language, like the given when then annotation, was majorly coined by the Cucumber project, which started fully open source. It is still open source now, but is heavily supported by SmartBear as a company. Cucumber is a tool that allows us to take these annotations, turn them into automated tools, which is one of the biggest essences of BDD that I find the most valuable here. Let's start and get Cucumber set up. What I have prepared is a small Ruby application that just replicates a very simple ATM interface that I want to implement BDD style tests or BDD style requirements with you. I already prepared the code, so we're going to mostly talk about how to automate tests around that, maybe see if there is anything wrong with that application, and if we can introduce new behaviors that are not yet covered. So let's get coding, and let's start off with getting Cucumbers installed and set up. Okay, so here we are. This is the web page of the Cucumber project. It's just https cucumber.io, and you will end up on this page. I have to admit that page looks a bit like you have to buy a tool with all that, free trial here and so on. But you don't have to. Cucumber is, although heavily supported and also sold by SmartBear now, there is a huge open source part which is called Cucumber Open, and this is what you're going to use. Cucumber Open is the open source part of the whole project, and this is where we go. So we go to cucumber.io/doc/installation, and it basically tells us everything we need to know. Just for completeness sake, there's also Cucumber Studio, which is a great tool. Just let me open that up here. Okay, I will go in there with my... Oh no, I don't have a Google account set up here. Okay, so it's a tool that really supports the whole BDD setup process. But all that you need to get started with Cucumber is the Cucumber Open version. You can also see it is hosted on GitHub. It's just freely available. It's open source. As you can see, installation is of course dependent on the programming language you use, because Cucumber integrates heavily with, and has to integrate heavily with software setup. So there's a difference to running Cucumber on the JVM in Java than to run it in Node.js or to run it in Ruby or in C++ or Go. As you can see, there's a huge number of languages supported and huge number of frameworks supported. In case there's something you're missing, it's an open source project. You can just add your own Cucumber adapter. I have plenty experience with using Cucumber in the Java or JVM version. I used it in Ruby, we used it in Node. I also used it in Go, and the whole Cucumber Diseases series that I'm doing is done with Cucumber and Go. And I also have good experience with Behave in Python and SpecFlow. I have to say, although it works with C++ code, Cucumber in C++ is a bit rough around the edges. It requires a bit more development setup, but if you're doing C++, you may be used to that. If I want to install it, and I'm going to do what I do here with a Ruby project, so the only things that I would have to do is gem install Cucumber. I have Ruby installed, of course, just to show you here. So I'm using Ruby 3.2 here. And basically all I need to do to get Cucumber set up is gem install Cucumber, and then it will do a lot of stuff in the background and get that stuff going. Okay, it's starting to fetch things. Great. So Cucumber is now updated. Okay, I get this warning here about there's a new Ruby Gems version, but I don't care for it at the moment. So what you can see now is Cucumber is installed. Okay, Cucumber version, and we'll see. I'm using Cucumber 9.2. So I have a project prepared in my BDD folder, which is called ATM. The project I have here consists of just two, or basically just one very simple Ruby file and a CLI so that you can play around with it. These sources are available on GitHub as well. I will link that in the video description so that you can take a look on your own. So the application that I have here is a simple replication of an ATM, and that's the, I don't know if you like class diagrams, but that's a class diagram. It consists of three classes. The most fronting one, and the one that we're going to interact with at the most time, is the ATM. That has a simple number of variables, like it has a cash box where a certain amount of money is in there. It can tell us which card was inserted, if the pin was entered correctly, and what it currently says on the display. So it kind of mimics a physical interface where you have the display and you can do stuff with it. What can we do with it? We can insert a card, we can enter a pin, and we can withdraw. That class has some logic in there, so you have to do things in the right order or you will get errors. And that will be the interface that we are, that's a user-facing interface that we're going to test for. The ATM uses a debit card. That's basically the thing that you put in there. A debit card is a very simple abstraction here. It just has a pin, it has an account that we have to give it when creating it. It has two functions we can call on it. The debit card can verify its pin, because only the debit card knows the right pin. And then we can withdraw from the debit card, which is linked to an account. And that account is basically just has a name, it has a balance, and we can update the balance here. So the biggest logic is handled in the ATM and in the debit card. Let's get coding. I'm going to use NeoVim here again. There's one thing I want to show you before we dive into the code. If you go to the repository, what you will see are two files. The one is the ATM RB, which is a Ruby file that contains the classes and the whole definitions, and there's the CLI, which is a command line interface so that you can interact with the ATM, with a virtual ATM machine. If we run that, it's a very basic and simple interface. It just gives us a menu where we can do things. We could do things in any order in this interface, and it always shows us the last message from the ATM. So we could say, for example, I insert a card, and then it prompts us to enter a pin. So we can say, let's enter a pin, and I can enter something, and it will tell us, oops, wrong pin. Okay, so we can also eject the card. It tells us, oh, card ejected successfully, and then if you, for example, try to check the balance, it tells us, oh, error, you have no card inserted. So you see there is some logic in the ATM class. There's a simple interface so you can play around with it and try different scenarios. And I'm going to say that the ATM Ruby classes, they are not perfect. They have some errors in there, and let's see if we can uncover some of them. Okay, so let's whip open the source code. I use NeoVim with a minimal Ruby setup. I don't have any debugging or anything set up, just a language server so we can see some syntax highlighting and some command line compilation. So this is the ATM Ruby class. As I said, I showed you the class diagram before. You can see here is our account class, which is referenced here. It has a name and account balance. We have the debit card here and the ATM class. The ATM class has a lot of logic. So it's already preceded in a good way, and we're going to start working on that. Okay, so that's the setup we have here. So let's get Cucumber set up. Let's just follow the installation guide that we have here. You see here, it tells us to initialize a new directory, we have to use cucumber -- init. So here we're going to run cucumber -- init. What happens if we do that? It creates a new folder and it creates some preceded code for us, some env that we could use to preset some environment variables or some specific setup that we might need. I'm not sure we're going to use that. And it creates a step definitions directory where we will put the glue code for our feature files. By the way, I like that graphics here. So Gherkin is the language that we use to write the feature files. It is given, when, then, and features and scenarios. And it is a nice mixture between having a living documentation, automated tests, and specifications that we can directly turn into executable code. If we now go and run Cucumber here, so Cucumber is also a command line tool, and if you run it, it should try to execute some tests, and we see we have 0 scenarios defined, so it executed 0 steps. So let's get going with our first feature file. We have to put it into the feature folder, and we're going to call it the withdrawal.feature. We're going to open up that up, and now we can start writing the feature as we had it before. Like we can say feature. So the first feature that we had was we can do a cash withdrawal from the ATM with a debit card. Okay, that's the first feature. Then we describe it, and I put the user story in there, like as a bank account owner, I want to withdraw cash from the ATM so that let me write it correctly, so that I have money available when I need it. As I said, like this part here, lines 2 to 4, this is just purely descriptive text. It is not going to be executed because the Cucumber interpreter works with the keywords. And then we are going to write our first scenario. So we have an account with sufficient funds. Okay, what does it look like? So let's think of what's the setup, the pre-setup that we need before we can withdraw the money. So given there is an account with a balance of 200. So I'm not going to bother with currency or anything, but because the ATM doesn't support it, so you're just going to put in some plain numbers. So we need to have an account with a balance of 200. And the debit card was inserted. And the correct PIN was entered. Okay, so that's kind of our basic setup. Like we have those 3 conditions. There's an account with enough of balance. I insert the debit card, and the correct PIN was entered. And of course, one thing that we also need is like, and the cash box contains 1,000. So that's our precondition. This is the point where the user behavior steps in. Now, what do we want to do? When I withdraw 150, this is the action that I perform, then the account balance should be 150. And no, it should be 50, right? Not 150. And the money is dispensed. And now we should be more specific, like and 150, and I receive 150 from the ATM, and the card is returned. So we have written our first scenario. Let's execute that, and in order to do that, we just go to our terminal and say cucumber. So what's going to happen now? It takes the definition and runs it, and then you can see it tells us, it gives us quite some output here. We see here our feature description, and it tells us the steps it executed and which line in the feature file they are. So that's already very neat debug information, and it shows all of them in yellow, because yellow means they are undefined. So the cool thing is, Cucumber out of the box tells us what we most likely need to put in our step definition. So we can just take all of that and copy it, then switch over to the step definition, and create a file. I think that should be sufficient. And put that there. Just copy and pasted it, and let's re-execute Cucumber and see what it tells us. Okay, cool. Now it tells us, it colored it differently, as you can see. It colored some stuff blue, which is skipped steps, and it tells one of them is pending, which is because Cucumber recognized through this linkage here, it recognized that this step is to be executed. So if we, let me split the terminal and open the withdrawal feature on the right side. So Cucumber works with pretty simple pattern matching. So we have a given step defined here, and that is there is an account balance of something, and through this pretty simple binding here, it recognizes this step is to be executed. And then, of course, it's just auto-reticulate that this is a parameter that we should have, obviously an integer. But here we call pending. And this is, in the default code Cucumber provides you, it gives you a definition where the steps are basically marked as they're not implemented yet, and this is the pending step. Okay, now that we can start making these tests pass, we need to set up a bit of environment variables, like we need to have our ATM available and the debit card and so on. So let's implement those steps one by one. So given there is an account with a balance of some value, okay, what we need for that is we need to first include or require our Ruby file that contains the code, like the ATM class, which is, I use require relative here to include the ATM Ruby, which defines all the classes. So for the first step, we are going to define an account, which requires a name, which is called the guy John Doe, because there's no requirement on the name at the moment. And I'm going to be split here once again. If we open up that here, we can see the account requires a name and an initial balance. Let's say our default account has always $1,000 available. So for that step, we need to get rid of that pending here, and just tell it that this account, the account balance of this account, basically is just our int value. Okay. So if we switch over now to the Cucumber part here and run it again, okay, we'll see now this step turned green because we implemented it and it didn't return in an error. So we can continue with the debit card was inserted. So for that, we are going to need our ATM defined, and as you can see, we will also need a debit card that we can insert. So let's create a debit card, which is pretty simple. With a debit card.new, we have to give it a pin, and I'm going to use a constant here. I call the correct pin, which is 1234. We need to initialize that with a pin that's assigned to the card and the linked account. Once we have that, we can create our ATM instance as well with ATM.new. Let's see here, it only requires the initial cache, which goes into the cache box initially. So let's say it starts with 1,000 as well. So now we have all the objects that we need to execute our tests up there. They represent our state, and this is not the best way to do it, but it's also something I cover in the Cucumber Diseases series. What's the problem with a global state? Okay, so the debit card was inserted. Let's implement that one. Pretty simple as well. So we're just going to call ATM dot insert, what's it called? insert card with our debit card. Okay, no error checking, nothing. Let's see if that works. If we run Cucumber again, okay, and then it shows us, okay, 2 green steps, 1 yellow, okay, which is the pin was entered, of course. So, given the correct pin was entered, let's implement that. So for that, we can refer to the ATM implementation. It has a function called enter pin. We just call enter pin, and it's the correct pin that was entered. Okay, and then let's continue the rest here, which is the cash box contains enough money. So we can say, what's it? Cash box equals int the value. So int is, by the way, this is linked here. This is like the first parameter we have here is the first one that we have here. Okay, so this is our test setup. And let's run that and see if everything goes green. Okay, so one thing that I would like to point out here, you can see in the test feature definition, it's here called given, and, but in the test step definition, it's always a given. This is because that and step here kind of attaches to whatever was written before. So if that's a given, then this and will be a given. If that's a then this and will be a then as well. Okay. Just to keep that in mind, you have to define it here correctly. So let's get down to the action. Now we are at the when I withdraw an amount. So let's clean that up. What do we have to do? Withdraw. There's a function on the ATM called withdraw. You can just say ATM.withdraw, and we'll just give it an int. Okay, let's get down to defining the first assertion in this test case, which will be done in this, then the account balance should be. So in order to get that correctly, we have everything we need here, okay? We just get the balance, which we have in account balance, and you can use different assertion frameworks, but the easiest thing here to do is we can raise our own error and say balance is this instead of the expected integer, unless the balance equals put in here. Okay, let's run these tests again and see what happens. Okay, and now we can see, oh no, there seems to be something off, because our tests run through, like it's green, it's green, it's green, and then it's red. At the step, the account balance should be 50, because the balance is 350 instead of 50. So we already found a bug in the application. So let's see, if we call withdraw, what will happen here? Withdraw, well, will tell us we're okay, enter the card, verify the PIN, and then it on the inserted card, it withdraws some amount. Oh, and here you can see, okay, you can see what our bug is. While we check for if there's enough balance on the account, what we do here is we update the balance, and update balance adds to the adjusted value. Okay, so let's fix that error, because we have to put a minus here. And if we rerun our tests, we can now see that this one passed. Okay, cool. We found the first error with our BDD implementation. Let's continue implementing. Okay, so all the things passed until I receive 150 from the ATM. So how do we get that? You have to know that the withdraw function returns the amount of money that was withdrawn if it was successful. So we somewhere have to save our withdrawn money, and I'm just going to do a very dirty thing here and introduce a global variable. So let's just save that there. Oh no, wrong stage. Say auto withdraw, we can say withdrawn equals this one. So we have to save it in our state. And now we can check here as well. Raise incorrect sum dispensed, And we can once again say, like, we have withdrawn instead of expected the value that we passed here, unless unless withdrawn equals the value we put in there. Okay, let's save that, rerun the tests, and we see everything run through, and the last thing that remains to be implemented is and the card is returned. Okay, so checking that the card is returned is rather easy. We should check that after we did all that, there is no card in the ATM anymore. So we just throw an arrow if it is in there, and there is still a card in the ATM unless the ATM card inserted is nil. Okay, let's run it through, and you can see this is how we implement the test scenario. Now we can also we could implement an additional one, like what should happen if we enter the wrong pin. And we start off in the feature file again with defining our scenario and say wrong pin entered, and let's say what should happen. So given there is an account with a balance of 200 and the debit card was inserted, so we have to do all that again. And now we can say when I enter a wrong pin, then ATM tells me that the pin is wrong. Okay. So that's a rather simple step that we just added. And when we run Cucumber again, it will tell us now which definitions are missing. So it runs the first one, it runs of the new scenario, it runs the first two because they are already defined, and then introduced two new conditions here that we have to implement. Once again, we can just copy that, just enter to our file here, and we can say when I enter a wrong pin. So let's implement that quickly. So that way, so we can say ATM.enter pin, and we just say wrong pin because it takes a string and it's rather simple. Then we should get an error. We have to mind here though that it will rise wrong pin on entering it, so we have to catch that error here. Last error, which is a variable we have to introduce, equals e.message, and now we go up here, say last error equals nothing. Usually we don't have an error, and then in the ATM tells me the pin is wrong, we just once again say raise ATM gave no error message if last error is empty. Okay, let's run it again, and everything run through because it gives us the right message. So this is the loop that we will enter through. Like if we would now define the next scenario and the next scenario and the next scenario, we would get more and more functionality into the application. We could even go now and implement like a completely new feature, like checking account balance, which we have not defined yet before, and could again say like scenario, I have a positive balance, and then start typing that out here and implement the test steps. Like this is how you use BDD and Cucumber. A couple of key points for the closing. First off, as you could see, BDD is based upon behavior. Everything that we did, also in the fumbling around with the code in Cucumber and Ruby a bit, we always took the user's view. Every scenario is defined from the point of view of a user. and we capture their requirements in a very structured and specific language. Then, as you could see with the coding part, with each scenario, we could build the behavior of our software and grow it step by step, which is pretty cool. And at every point, we had this automatically executable tests, which I think is a pretty neat feature, and is actually what makes the whole Cucumber thing very worthwhile. So then, the way we worked, we have to understand that BDD is a high-level development approach. It is agile inspired. It has to do a lot with communication, and all of that. It's a test-first approach. Just refer to how I created the scenarios. First off, I create the scenario, then I implement the test code, then I come across something that doesn't work or is not yet implemented in the application, so my tests go red, and then I implement that. This is basically a TDD or acceptance test-driven development loop that we can go in, but also it is very high level. It focuses on the end-to-end interactions. We did not write any unit tests in this code. I did not take any of the functions of the ATM or the account and test that, but I always did end-to-end integration tests with the code. So I only know it from as a black box. You have to keep that in mind. BDD is not a unit testing approach. It's not very low level. It's very, very high level. And it requires that your code has the right level of abstractions involved so that you can test it very easily. And you should supplement it with TDD development approaches, or more unit testing, more additional test automation. I think that Cucumber is a pretty neat tool. It is a full tool suite for multiple languages that supports BDD style development. It is fully automated. It already tells you which test steps to implement. You've seen it today in Ruby, but if you do that in Go or in Java or in Rust, it tells you where to put which code. And with a little bit of customization, it's running out of the box, turning your written requirements and written examples into executable test code. And that's the essence of today's video. I hope that this video gave you an idea of what Cucumber and BDD is, at least on a very rough level, seeing some first-hand things. Even if you don't know Ruby, that you got an idea how it works. And if you're interested in some of the things I may have done wrong here, like I used some bad testing practices, like having global states just in the step definitions. This is why I created the Cucumber Diseases project together with my colleague Roland Gam. Link is down below. I will also link the video, or the first video of the series, where I go through all the smells that we identified there. Also somewhere here. And in the next video, I'm going to talk a bit about what happens behind the scenes of Cucumber and of the test execution, so you get a bit more understanding of what's behind the black box and why that creates a bit of a different scenario for writing good test code. Okay, so far I hope you had a great time, and I wish you a great remainder of the day. If that was interesting to you, watch in again and leave a comment. Have a great day.